Time for our next talk. But before that, a quick shout out to our sponsor, Maze, one of our bronze sponsors, and without them, this event would not be happening. So thank you, Maze. And pleasure to introduce Joel, who's going to be talking about from 1 to hundreds, reflections on a decade of building the trenches. So thank you, Joel.
Thank you very much, Mohit, and thank you all for coming to this talk. I want to give a quick bit of background about myself to tell you the perspective of where this is coming from. Earlier this year, I left a company where I'd been working very closely in AWS for over a decade. Now, the specific company isn't important, but I do want to note that all opinions I'm sharing today are my own and not those of my former or any future employers. And when I started, we had a single test AWS account. This is the account where all of our dirty laundry was, where we made all of the same mistakes that every new person at AWS makes. And as we started growing out and getting a more complicated AWS footprint, I became responsible for developing and building a lot of our, what I would call AWS enterprise patterns. So these are things like, what's our network architecture look like in AWS across our account fleet? How do we think about securing the account fleet? What are our service control policies? That kind of thing. And as we grew, we got to the scale where we had somewhere on the order of hundreds of AWS accounts. I also think it's important to note that I've always considered myself to be more of what I would call a secure builder. So I'm always trying to build solutions to problems in a way that's highly secure, but I've never actually had security in my official job title. And as part of that, I was building the foundations of our AWS footprint in a secure fashion, but I also had responsibilities to build business-facing applications to the company on top of our AWS footprint. So I think that gave me a really valuable perspective in eating my own dog food. I was ensured that our AWS footprint kept the company secure, but also enabled teams to do what they needed to do, ship software, and deliver value to the business. So the early days started working with AWS sometime around fall of 2013. And I think it's important to note that as we were building all of this out, this is a journey through time. We had to build with the cloud we had at the time we had it. Not the cloud we wished we had, and not the cloud that we have now. And just to give you some context, back in 2013, shortly after I started, I remember this AWS feature launch at reInvent 2013. They launched a little-known service called AWS CloudTrail, now considered to be the cornerstone of any AWS security footprint. And lastly, we had a very federated technology model. So we'd have centralized security policies and centralized security controls. But then we wanted to have federated technology teams who were empowered to be as self-service as possible so they could deliver what they needed to deliver. So as we started building out, our early hypothesis, somewhere on the order of around 10 accounts, is we wanted to think about AWS accounts as cattle, not pets. Those of you who were around at the time may remember we were talking about servers as cattle, not pets, that they would be short-lived. We would spin them up on demand and then throw them away when we no longer needed them. And for all of those reasons, we believed that we needed to treat our AWS accounts in the same way as much as possible. So we would want potentially a large number of accounts, but a small number of different account shapes so that we could reason about them and secure them properly. And for the same reasons, we would use tooling like Chef or Puppet to configure our servers and make them all conform to a template. We would need to do AWS accounts as code in order to make sure that all of our accounts met the same security baselines and templates. And lastly, we wanted to practice the dry software development project. Don't repeat yourself. We don't want to have and repeat hundreds of individual low-level security properties across every single account in the fleet, but we want to bundle them up into higher-level abstractions. And then when we talk about an account, we can just say this account should be this particular abstraction. And that's what I'm referring to here when I say it's a shape. So for the purposes of this talk, we'll have two shapes, secure and playground. I assume that these will need no introduction. And lastly, I want to talk a little bit about some of my security philosophy when it comes to a decently sized AWS estate. So informed AWS security decision-making means you have to be able to reason about the accounts. You have to understand all of the relevant security properties of the accounts that you're making decisions for. But if you want to be efficient and make efficient security decisions, it requires a small number of these account shapes. And the reason why this is so important is, first of all, it creates reusable precedent. When someone comes and asks me, hey, can I do X in a secure account? Well, the next time someone comes and asks, can I do X in a different secure account, I don't have to re-answer that from scratch. I don't have to reinvent the wheel. That precedent is already there. The reasoning has already been developed. Now, the second reason is it gives you a quicker recall about each shape. You're not trying to think about 100, 200, 300 different accounts and the nuances between them, but you've got 2 or 3 shapes, or 4 or 5, or whatever is right for you, and therefore you have less to context switch back into memory. And then the last point I want to make is that when you do this, you can gain deeper knowledge about each shape, and so you gain deeper insights about what all of the trade-offs were, why they were made, and what the implications of those are, and that's going to make you better able to secure your business. And then the last point I want to make is that you should only ever trust that which you can prove. So for example, if a developer comes and says, hey, can I store all this really secure data in an S3 bucket? And by the way, I promise, pinky swear promise it's not public. Please do not trust those. Please verify this for yourself. So with that out of the way, I want to kind of talk about reflections in 3 broad areas. The first area is going to be around the tooling that we built for this. The second is going to be in some of the CI and CD patterns we used for developing on it. And then the third is going to be around some of the account patterns themselves. So onto the tooling. So the first thing we started with is having a declarative computer-readable inventory of your AWS accounts. So on the right is a sample as to what this might look like, where when I say it's declarative, you'll see that it tells you all of the accounts in your estate, and it tells you what the shape should be. It does not tell you how do you get those accounts to look like that shape. It just says what your desired state is. Importantly, this also must become your source of truth for what is in your account footprint, because that is going to drive everything else that you want to try to automate and scale out as you build further and further. And lastly, this could actually become an interface for other teams to look at. Other developers may look at this and say, oh, now I know exactly what this account looks like without having to go into and look at production directly. Or other developers who may be more enterprising might even open up a pull request and say, hey, I want to make this change to this account, so here's my pull request instead of just submitting a Jira ticket. Now, we have this declarative inventory. Now we have to then turn it into reality. The approach that we took was we would generate CloudFormation templates for each account. At the time we were building this, stack sets didn't exist, so we weren't able to use that. And as we started scaling out and getting to more complicated shapes and more complex features, we would start frequently running into different CloudFormation limits. The 2 that we kept running into that were the most painful to deal with was CloudFormation logical resources per stack, as well as the size of the JSON template that you could pass in. Yes, I minified the JSON template. No, I'm not proud of it. And yes, I'm apologizing to everybody who has to debug these in the future. On top of that, CloudFormation, it's a different story today, but historically it's been hard, if not impossible, to non-destructively refactor your stacks. You can't just say, hey, I've got a stack, let me take these resources and move them over into a different stack. Because if you try to do that, just naively, CloudFormation is going to try to delete these resources, come over here, and then recreate them in the new stack. And when the resources you want to move is your production network, that just doesn't work. And then the last point I want to kind of make here that was interesting is that CloudFormation itself always just felt slower to converge and complete than something like a Terraform. And that just meant that that was a constant tax that we paid as we were doing development and testing and debugging work. Now, I do mention Terraform, and maybe Terraform would have been better. I don't know. We didn't use it for this. It might have been worse. The only thing I'm sure about is that we would have run into different sharp edges and different limitations of Terraform had we chosen that instead. And so the key takeaway I want to leave with this isn't CloudFormation versus Terraform. It's as you're building these toolings, try to understand what the limits of this are. As you scale it out, what are you going to run into? Because it's much easier to design around these limits ahead of time than when you're running into them into production. Now, as I'm sure those of you who've used CloudFormation know, CloudFormation can't do everything. And so we ended up also having to write some custom code to fill in those gaps in CloudFormation functionality. And because we have a declarative inventory, the custom code that we're writing has to be item potent. And that idempotency adds complexity because not only do we have to be able to run it over and over against the same state and do nothing, but it has to be able to handle and correctly transition from any one valid state to every other possible valid state it can get to. And this complexity does have costs. It costs more in terms of developer time to write the code. It costs more in the testing complexity to test it and validate it and make sure it works properly. And then it's a potential source of bugs, which then adds more costs in terms of developer time and testing complexity. And so really the takeaway I want to leave you here with is that this is a trade-off. I think this trade-off is well worth it, but it is something to be aware of going into it and just understanding that this is one of the consequences of what you're signing up for. And then the last thing I want to talk about is dealing with unexpected requests, because you want to have some centralized governance and control over your account fleet, and inevitably somebody is going to come in with a request that was just not expected. It's kind of new. It's not their fault. They didn't really know this wasn't supported. And there's going to be a lot of pressure to just click in the console. The problem is that this quickly becomes a slippery slope because someone says, hey, you clicked in the console to fulfill this Jira request. Why can't you do it to fulfill mine? And one-off console clicks make your inventory incomplete, untrustworthy, and require tribal knowledge to really understand. When you start off, your inventory might look like this. It's relatively simple. You click in E, and you can maybe understand B and E aren't really the same shape anymore, but you remember that you did something in E. However, as you grow and scale out, your inventory starts looking like this, and then it starts looking like this, and then it starts looking like this. And this is the simplest possible inventory you could have. So when you get to the scale, it's just no longer tractable to understand and trying to remember what was done on a one-off basis. So when it comes to console clicking, please just say no. However, you can't say no to the requests that come in. You have to still enable them. And you also want to avoid shadow AWS because that's even worse. And so what you need to do is maintain some engineering flexibility to be able to handle some small unexpected feature requests on demand. I'm not saying turn something huge around the next day, but this might be something like, oh, AWS released interface VPC endpoints. Can we start using them? And then you take it and then turn around and offer that out in, say, a week's time, where now that aligns generally with a lot of developers' delivery timelines and their life cycle. And if you can do that, that's a great way of staying agile and enabling your developers to do the work they need to do. All right, so now I want to talk a little bit about CI and CD. The first thing I want to bring in here is that I very much pushed for, and we had what I call an open source-like philosophy for our tooling. So it wasn't true open source, in that it wasn't open to the internet, but all developers in the company could see the code, and all developers in the company could submit pull requests. They could not approve them, but they could certainly submit them. And I think that really helps foster a collaborative relationship with our developers, because code is the language they can speak. If they just see Jira tickets, they're going to say, why isn't my Jira ticket done? But if they see the code base and see that you're working on developing code base, then that helps them understand the world that you're living in, and again, creates that relationship. But it also empowers developers, because we had a number at my last company where they would be interested in implementing these features themselves. And so it gives them the power and the ability to do it, and for you, it's actually a source of free labor. So it's a win-win, right? The next thing I want to talk about here is around testing. You have to invest in automated testing, because this is the thing that is controlling the most fundamental and secure aspects of your production AWS accounts. So you have to get this right. Unfortunately, now, as I said earlier, our vision was AWS accounts as cattle, not pets. So you'd ideally want to spin up, every one of these tests, spin up a new AWS org and a brand new fleet of AWS accounts, run all our tests, and throw everything away. And unfortunately, that's just not feasible. AWS has made a lot of improvements over the years to it. But still, I think it wasn't quite the ability to just spin up a bunch and then throw everything away right away. So what we ended up doing was creating a dedicated AWS organization just for running the tests, and then we'd pre-create a fleet of AWS accounts, so that when the accounts run, there would be some sort of reservation system. An account might say, hey, I need, say, 3 AWS accounts for this test. It would find 3 free ones in the reservation system, mark them as used, run the tests, and at the end, throw everything away and release them. It was certainly imperfect. For example, failed tests would frequently leave orphans behind that would cause future tests to fail. And so certainly this was imperfect. I think the approach was a reasonable trade-off, but this is something where I think we needed to spend more time in investing in ensuring the quality and speed of the tests, because it was just a constant drag that was also a big morale hit. So testing is very important. The last thing I want to talk about is a couple of account patterns that we used to federate out AWS to different teams. The first thing I want to talk about is DNS, because let's be honest, I love DNS, and I'm sure all of you love DNS just as much as I love DNS. And so what we would do is delegate out DNS subdomains to individual AWS accounts. So on the right, you might see what this looks like in an inventory. So account C gets DNS subdomains for cat and cow. Apparently, it's for animals that start with the letter C. And what our tooling would do is when this goes into the inventory, it would create the cat and cow subdomains in account C. It would then create delegation records in the parent Route 53 hosted zone to point to the child hosted zone. This would allow the account owner of account C to fully self-service any DNS changes they made, but just for those DNS subdomains. And we could also validate that there were no DNS subdomain name collisions, so this acted as a name reservation system. This also allowed account owners to fully validate any ACM, like public ACM certificate requests, all on their own. And as a result, there was no longer any excuse anywhere for not using TLS. So all developers used TLS everywhere, and it was great. But in addition, because AWS auto-renews ACM certs when the validation records stay there, it also meant that we just eliminated TLS certificate expiration incidents. So better reliability in TLS everywhere, I think, was a huge win. But in addition to that, it limited the blast radius of DNS changes. If you consider the worst case scenario of account C is completely compromised, the worst that it can do is muck with DNS records in these two subdomains in cat and cow. It couldn't, for example, touch DNS records in dog.example.com. So we then contain the blast radius of anything that could go wrong. And this also applied to, for example, testing deploys. So for our QA cat application, well, that's, of course, going to be deployed to a different account. That's going to have different DNS changes associated with it. And any DNS changes in that testing deploy couldn't possibly interfere with your production DNS zones. So I think that was also a big win in terms of limiting down the blast radius of any DNS changes that were made. The other thing I want to talk about here, and this is something I could spend hours and hours on, but I promise I will go quickly, is VPC endpoint policies. So I've seen a tendency for people to think that VPC endpoint policies should be used for application security concerns and like try to narrow down which parts of which applications should be able to talk to which parts of which S3 buckets. And if you try to do that and govern that at an organizational level, it just becomes an impossible mess. Really, the right use for VPC endpoint policies is for data exfiltration concerns and data perimeter concerns. And as we built out VPC endpoint policy support and controlled them, the pattern that we observed was that the vast majority of accounts only needed to use VPC endpoints for principals in that account talking to resources in that same account. So on the right, you might see one way to model this in your inventory, where EC2, maybe you need to make something external, but right now EC2 is going to be the default, same account, same principal, so there's nothing there. But S3, there's always an exception, and it's usually S3. We all know this. Maybe you need to talk to the Starport bucket, which hosts the ECR repository, so you need to be able to enable access to that S3 bucket. So maybe you model it that way as saying, hey, our external buckets include the Starport bucket. We would just take this and compile this down into a VPC endpoint policy that changed over the years as what we were able to do changed. And so where I ended up on, and this I think is my favorite policy, is allow star, principal star, resource star, but then put conditions on AWS principal account and AWS resource account. So I think this very closely implements the semantics we want to say, hey, this VPC endpoint is only for principals and resources in this account. And that prevents foreign principals from talking to foreign resources. And that's a way of very easily understanding how you're going to have any sort of data exfiltration controls on building a data parameter. So conclusions. First of all, you have to start with a decorative inventory of your accounts that has to be complete and the source of truth. This has to then have the right types of account shapes for your business. You want as small a number as possible. They also need to be extensible. You can't have like secure or secure with EC2 endpoints or secure with EC2 and S3 endpoints, because when you start having that level of variation, it gets intractable. So you want composable, extensible shapes that you can put in your inventory that make sense for your business needs. You're going to need your tooling to then translate this inventory into reality. And then you want to treat this as a first-class software development project with appropriate CI and CD and testing and security reviews to maintain the health of it. So thank you very much. If you want to contact me, there's my contact information. There's a feedback form on Slack as well, so please fill that out. Thank you.
Awesome. Thank you, Joel. I think we have a question there.
Hey, thanks for the great talk. We went through a similar journey, so also thanks for the inspiration for what we could do better. One thing where we are always a little bit unsure is like what belongs into like the account baseline that's like managed by your team, my team,
Yep.
and what is then like responsibility of the respective team running their workload in one or multiple regions. And that's the point of my question. Like some teams, some applications run in like 10 AWS regions and some only in one. We would like to provide KMS keys in every region, costs money. So what's the trade-off? How do you decide about those regional resources, which would be good to have there by default, but come with a little bit of costs, and that's why you don't want to have them everywhere by default?
Great question. I mean, I think some of it's going to depend on the cost sensitivity of your organization. How do you think about like, what's the downside of, say, adding something new? And so, for example, maybe in your account baseline, you have a parameter that says, here's all the regions that this should be in. And then think about, like, what are the most common patterns across your company? So if, the 10 regions is the one-off, then, like, that's where you specify regions. But if virtually everybody is across 10 regions and you have something that maybe is only 2, then maybe that's the exception. So start thinking about, like, what's the most common, what's the exceptional, and the phrase I always say is, the easy thing should be easy, and the more complicated things should still be possible. Does that answer the question? Okay.
Hi. So would you expect an application developer who's maybe using one or just a few of these accounts to hook into that system as well? You might have an attribute that says that account runs application X, or would that create weird bottlenecks?
Yeah, so I mean, I think it really depends on like your team and org structure and how much people go behind. But I think about we should try to basically build whatever accounts a team needs. So, for example, maybe you have standard development, QA, staging, and prod, and so that's 4 different accounts. Maybe they come along and say, hey, we're doing a external pen test. We want a new environment for that pen test that can't touch anything else. So maybe that's the 5th account. And then when they're done, you throw that away, and that gets down to a 4th account. And then maybe it turns out they say, hey, we really don't use our staging environments. So then you close that down. And so I think really the more important thing isn't necessarily figuring out that answer up front, but how can you be flexible and support the teams as their needs evolve through time?
Hey, so I have a question about the direction of platform engineering when it comes to, sorry, I'm over here.
Oh, thank you, sorry.
So for us, we're trying to embrace the zeitgeist of platform engineering, have a bit of a self-service platform for our developers so they can scale independently of our infra team. And the account would be one of those blueprints we would provide. I'm assuming you're a bit more mature in that direction. What were the next steps after you kind of automized the account vending? And I'm not talking about control tower level of automation, but what you're doing.
I mean, I think that's a great question. I think at this level, that more or less met the needs of the business in terms of the steady state. And I think it really just comes down to what do you find yourself doing? Are you constantly trying to fix the tooling? Are you responding to different requests? How can you enable yourself to handle those requests more easily? There's also another aspect of like, hey, as AWS rolls out new features more broadly, so a recent one would be resource control policies. And okay, what's our strategy for now adopting that new feature into the organization and making sure that you're set up with your consumers of these accounts so that you know how to do it safely in a way that's not going to break production. So do you have a set of accounts that, the thing I always say is, can we have a set of accounts that are marked as canary? And so, we'll have, I said we've got, secure and playground, but really you may have secure canaries, playground canaries, and so you always apply to canaries first before moving up. And so working with our business users on organizing that and keeping that up to date and refining that so that we can better adopt and make it easier to roll out these new features as they come out.
Awesome, thank you.
Cool. Go for it.
Thank you. Yeah.
So how do you handle lack of support in CloudFormation for new features in AWS? And over time, as they add the support eventually, to migrate over to that and make sure that happens?
Yeah. So there's always just when new features come out, we don't necessarily have people who are clamoring to use them right away, and especially not at this low of a level. And so if CloudFormation can support them when people want them, great. If not, we often find ourselves writing that custom code that I was talking about, which then it comes into the, and again, when we started, CloudFormation custom resources wasn't a thing. And so there's just always this cost benefit of, if it works for this thing, like, do we need to fix it or not? And so trying to evaluate, like, is there a maintenance burden for this bit of custom code? If so, would it make sense now to move this off to CloudFormation or not? And so more just kind of addressing that on a case-by-case basis as it comes up, rather than having a generic policy or viewpoint.
Awesome. Thank you, Joel. If people have any more questions, please, I assume Joel's happy to receive them afterwards.
Absolutely. Please, happy to chat in the hallway afterwards. Thank you.
Thank you, Joel.